Let's take a look at a third degree polynomial. Solve the given polynomial equation. Okay, so they've phrased this question differently. If you go back to this problem we just did, it said find all roots of the polynomial equation. So they're really testing your vocabulary here. Okay, finding all roots means finding all of the zeros, right? And how do you find zeros? By setting the equation equal to zero. So even though this problem doesn't say the same thing, okay, you're going through the same process. They're setting the equation equal to zero, and when they say solve, they want to know, okay, what values of x produces zero, produce this, right? And by definition, that's what zeros are. So when they say find the roots, or they say find the zeros, or they say solve the polynomial equation that's set equal to zero, it's all the same. All right. Now, when they say use the rational zero theorem, again, we did not cover this in my class, okay? And we did not cover Descartes' rule of signs, only because René Descartes did not have Desmos, and we do, okay? So we're going to leverage that. Now, when you look at this four-termed polynomial, we've talked in the past about, one way of finding zeros is finding all of the factors, right? And then setting each factor equal to zero. Okay, we kind of did that here again in this previous problem where we had all of our factors at one point, two linear factors and a quadratic factor set equal to zero. And then we could find the zeros from these by taking the opposite, and then we set this equal to zero and solved, right? So that's been a process that we've been working on for a couple of classes now. So even though they're not saying it, we're still going to factor this. But when you look at this problem, right, in a four-termed polynomial like so, and you're like, well, I know I can factor by grouping. Okay, let's try it. What's the common factor in this first group? 9 and 12 are both divisible by 3, and they both have an x squared. If I take 3x squared away from 9x cubed, that's 3x. If I take 3x squared and factor it out of here, that leaves me with a minus 4. And when we factor by grouping, we rewrite that term and try to figure out how we can take something away from negative 8x in this second group to end up with 3x. And what do I divide this by to get 3x, right? That's a totally different ball game. It's just not going to work, right? There's nothing. You're not taking away 5. Like, don't start thinking addition and subtraction, right? 8 is not divisible by anything to produce a 3, at least in terms of integers, and we'd like to avoid these fractions if possible. So the bottom line is trying to get 3x minus 4 from negative 8x minus 1 isn't going to happen. So factoring by grouping doesn't work, all right? So we're not going to be able to factor this way. So instead, we're going to go to Desmos, okay? And we're going to use this technology to help us answer this. 9x cubed minus 12x squared minus 8x minus 1. Okay, now we come in here, we see this number, we see this number, and we see this number. Now, when you see these three intercepts, and we can zoom in if you want, okay, here's what I'll say about this. These two values look like they're approximations. This one, not so much. So even though the technology does make it easy on us to see these intercepts, all right, we need to be a little bit more skilled and a little bit more precise with our answers, right? So being precise. This 1.847, that's a decimal approximation for this answer, right? When you look at these three decimals, negative 0.333, that should ring a bell, right? This is negative 1/3. This, negative 0.18, do you know what that is as a fraction? Do you know what 1.847 is as a fraction? Probably not. But those are the answers that these math programs are going to want, that the ACT, the SAT, that's what they're going to want. They're not going to want the decimals, okay? So, long story short, we have a zero that we can definitively say, yes, this is negative 1/3. So we take the zero that we know, we say, okay, one of our zeros is x equals negative 1/3. Now that we have a 0, I'm going to do synthetic division with it. I'm going to take that number and I'm going to synthetically divide this polynomial by that number. The 9 comes down. Negative 1/3 times 9 is negative 3. Add, we get negative 15. Negative 1/3 times negative 15 is positive 5. Add, we get negative 3. Negative 1/3 times negative 3 is positive 1. Add, we get a 0, just as we expected. Okay, so this means x, this means that because the synthetic division resulted in a remainder of 0, x plus 1/3 is a factor. All right, so here we go. What am I left with? We've talked about this before, but we'll mention it again. This represents 9x cubed. Every time we do a division like this, a synthetic division or a long division, we end up with one less here, one less from the exponent in this case. So 9x cubed, now it's 9x squared. This is minus 15x, and this is just a constant, right? These always get knocked down by 1. So where we stand right now is instead of this function, we have x plus 1/3 and 9x squared minus 15x minus 3 equals 0. So now this is what our problem looks like, okay? Now let's get weird with it for a second, okay? Follow along. This x plus 1/3 is kind of odd looking, right? When you look at this trinomial and you see the numbers that are listed here, 9, 15, and 3, okay? All of these numbers are divisible by 3. So what I'm going to do is I'm going to factor a 3 away from all of this. And instead of putting it right in front, I'm going to move it all the way up to here, okay? So this is 3x squared minus 5x minus 1. And that's equal to 0. Okay, so here's where we currently stand. I'm supposed to find all of the zeros. I already know what one of them is. It's negative 1/3. The other two zeros are hiding in this quadratic. Okay, now normally, stay with me, normally we would say, oh, this is a quadratic trinomial, so I can definitely factor this. I just got to find the right mix of numbers. Okay, but we've already ruined the ending to that movie, because these are those numbers, okay? Negative 0.18 and 1.847, right? Those are the numbers that you would find in these two places, right? Along with the 3. So it's a little bit more complicated than that. Factoring this is going to be impossible, okay? So factoring, not an option with this quadratic. Instead, because it is a quadratic, and I can set this quadratic equal to 0, how do we solve quadratic equations that are set equal to 0? I referenced this in another video. We always can fall back on the quadratic formula, okay? Just when you thought you didn't need it, you're like, when am I ever going to use this? I learned about it in algebra. Well, we're using it now. We've got A, B, and C listed here. Let's go to work, because this is going to give me those two values of x. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Remember that? Do you remember your quadratic formula? I'll write it up here real quick in case you don't. Put this in your notes, right? Some people memorize it by a song, right? Some people just know it. Some people are 39-year-old math teachers and have done this for 18 years and just remember what this looks like, okay? So when we solve this, the opposite of negative 5 is 5. Inside this quantity, negative 5 squared is 25. And we have negative 4 times 3 times negative 1. That's positive 12 all over 6. Okay? Nobody said this was going to be clean, right? So what do we end up with? 5 plus or minus the square root of 37 over 6. Now, normally we would look at this square root and try to find something that we could break this down into, but it's just not going to happen. So let's go back to the beginning of this problem, something I forgot to mention, which is pretty poor. This is a third degree polynomial. Because it's a third degree polynomial, that means it has 3 zeros, right? Now we saw all of those zeros here, but we said like these two zeros had odd looking decimals. This one was one we were probably comfortable with. These two are not. And if we want to be precise with our answer, we're not going to give decimal approximations. Okay? So our other 2 zeros are right here, right? We have the one where we include the plus sign, 5 plus radical 37 over 6, and we have the one where we include the minus sign, 5 minus radical 37 over 6. These are our other 2 values of x that will produce a value of 0, right? That was the whole purpose, right? We already knew this one, right? We knew this was x equals negative 1/3. We saw that from the graph, okay? The other 2 came from this quadratic. We couldn't factor it into integer values or easy numbers, so we went straight to the quadratic formula and used that to find these other 2 missing values. Here's all 3 zeros or all 3 roots for that third degree polynomial.